Okay, so here's I-2, the video. We're just going to do one example, and then there's practice on delta math. So just do as many as you feel, as makes you feel comfortable. We've actually been doing this before. Okay, it's just kind of in a different context. So convert the polar coordinates 4, 5, pi over 3 into rectangular form. Express your answer in simplest radical form. So with rectangular, polar. With polar coordinates, the coordinates are not x and y. They are r and theta, okay? So just a little quick demonstration. So rectangular coordinates are like 5, 2. You go right 5, you go up 2. But polar coordinates, so these would be like x and y. But polar coordinates, the first coordinate is not an x coordinate, it's a radius. So the first coordinate tells you how big they want you to draw a circle, what the radius of it is. And then the second coordinate is not a y coordinate, it's theta, and it tells you how much you rotate on the original circle, how much you rotate from here to get to the point. Okay, so a coordinate system is just a way of stating location. So these are two different ways of stating location. So right now, you don't have to draw this picture, but they've told us about this point here. Okay, so 1, 2, 3, 4. All right. And then think of the pi over 3 circle. Right, and you don't have to draw the picture when you're doing it. I'm just demonstrating. Is everyone with me so far? Yeah. Okay. And so I want these coordinates tell me to be on a circle of this size and then to travel this much from the initial point. So 1, 2, 3, 4, 5. So this is the point right here. But what we want to do is we want to figure out how many right and how many down would make us land at the same exact point, okay? And the way you do that is with this formula. So this is always true, and we need to know this. So the x coordinate is r cosine theta, and then the y coordinate is r sine theta. If this was a unit circle, if the radius was 1, then r would be 1. You know, so you have x as cosine, y as sine, so same as usual, okay? But this time our circles can have radius bigger than 1, so that's why we put the r in front. Yeah, so guys, to get the x and y, you just plug these in. So x is going to be 4 cosine of 5 pi over 3. Okay, and then y is going to be 4 sine of 5 pi over 3. Okay, now I'm not going to use the same circle. I mean, I suppose you could, but I'm going to use, when we're evaluating sine and cosine, it's a unit circle that we're using. So it's just a circle of radius 1. All right, so 5 pi over 3. Okay, so I'm landing there. So I need the coordinates of that point there on the unit circle. Guys, I'm going to ask you if anyone remembers.
Was it on that sheet?
It is, but we did have a way of doing it thinking like short, long. See if you can do it that way. You don't have to. Yeah, square root of 3 over 2, you got it. Okay, so guys, this has the short y, so a half, and the long x, so radical 3 over 2, but negative. You could also use the sheet that I gave you. That's all on the sheet. Okay, so now we just plug these in. So this is going to be 4. What is going in for cosine of 5 pi over 3? Take your time.
You don't distribute cosine, do you?
You don't. Take your time. So basically, we need to know what is cosine of 5 pi over 3. It's a half. Exactly, it's the x coordinate. So this is cosine of theta, that's sine of theta. It's the x coordinate on the unit circle. So a half is going in here. So that ends up being 4/2, so that's 2. And then what is sine of 5 pi over 3?
Square root of 3 over 2.
Exactly. Yep, negative square root of 3 over 2. So this ends up being negative 2 radical 3. So the final answer, guys, is 2 negative 2 radical 3. So this is another way of reaching the same point. You go right 2 down 2 radical 3. Okay? So we're just converting. You don't have to do any of like this picture stuff here. I just wanted to demonstrate. But yeah, you're just using those formulas. And use your sheet, guys, if you're a little rusty on when we, had that stuff memorized. Okay?